Today we discuss this chapter differential equations. So this is one of the most important topic from 12th class to engineering. Not only for that subjective part, even for CET, means common entrance test like KCET, MHCET, different states are conducting a common entrance test. So for that and MSET and mains and advanced level also. Very most important topic. So generally we are feeling differential equations is very difficult chapter, right? But it is not difficult. Before also I told you, na. So if you are perfect with differentiation and integration, it is very easy. Okay, so I will explain that differentiation and integration formulas also when it is required. Okay, so first we discuss about what is the definition of a differential equation. So after that, what are the types of differential equations? After completion of that, how to find order and degree. Then after completion of that, how to form a differential equation. After completion of that formation of a differential equation, then first order and first degree differential equation, definition, and what are the methods to solve first order and first degree differential equations. Okay, and in that only one of the method variable and separable, and second method is homogeneous, third one is non-homogeneous, and fourth one is linear differential equation. In that two types. So application of linear differential equation is a Bernoulli's equation. So up to Bernoulli's equation, that is for mains as well as PU board, means NCERT. After that, few more methods are there: Newton's law of cooling and natural growth and decay. So those are all applications, those are for advanced level. So after completion of that one, then we'll discuss linear differential equations with constant coefficients. So that is purely for engineering. Okay, so complete from starting to ending. So I'll give full details about that differential equations. After completion of this, then we'll go to the next chapter. Okay, so now first we discuss definition, means how to define a differential equation. So this is the definition, and here, so this is one of the given curve, y equal to f of x, right? Now differentiating with respect to x, then derivative of y with respect to x is dy by dx, and it is f dash of x. And in this derivative dy by dx, y is called dependent variable, clear, and x is called independent variable. Y is called dependent variable, x is called independent variable. Suppose the derivative is dx by dy, dx by dy, x is dependent, y is independent, clear. And here, so these are the examples. First one is dy by dx, 2xy, 3x square. Second one is d square y by dx square, 2x dy by dx plus 3y equal to 0. And the third one is dou u by dou x plus dou u by dou y equal to 0. Fourth one is x square into dou square u by dou x square, y square into dou square u by dou y square, z square into dou square u by dou z square equal to 0. So generally these equations are called differential equations. Okay, and if you take first example, so here derivative is dy by dx, right? Suppose if you want number of dependent variables and the number of independent variables. dv means dependent variable, iv means independent variable. So in this example, derivative is dy by dx, right? So in the derivative dy by dx, y is called dependent, x is called independent. So one dependent variable and one independent variable. Similarly, if you take second example, there are two derivatives in that, right? One is dy by dx Another one is d square y by dx square. But if we differentiate dy by dx again with respect to x, then we get d square y by dx square, right? Means we are differentiating y with respect to x only, na? So here also one dependent variable, one independent variable. So it is equal to 1 and it is also equal to 1. And coming to this third example, so number of dependent variables equal to, so dou u by dou x, dou u by dou y. U is the dependent variable, so that is 1. And coming to this, number of independent variables, so x and y, so that is 2. And last example, so number of dependent variables, again here also it is equal to 1 only. And coming to independent variables, those are 3 x, y and z. But why these equations are called differential equations? For what reason? So we are calling differential equations. That is the main thing. So it's a very simple definition. Take any equation. So this equation involving only one dependent variable, right? And few derivatives are there, either dy by dx or d square y by dx square or dou u by dou x or dou u by dou y or dou u by dou z. And independent variables either one or more than one. So by using these three conditions, we define differential equation. So definition: an equation involving one dependent variable and its derivatives with respect to one or more than one independent variables is called a differential equation. What is the definition? An equation involving one dependent variable and its derivatives with respect to one or more than one independent variables. Okay, so now I am writing the definition. An equation involving one dependent variable and its derivatives with respect to one or more than one independent variable is called a differential equation. So this is the exact definition of a differential equation. Clear? Now, what are the types of differential equations? That is the next topic. Next topic is types of differential equations. So generally these are two types. These are two types. First one is number one, an ordinary differential equation. In bracket ODE. Second one is a partial differential equation. That is PDE. So again I am taking same examples, but in these four examples, first two examples are called ordinary differential equations. Third one and fourth one are called partial differential equations. But why 1 and 2 are called ordinary and 3 and 4 are called partial? What is the difference between ordinary and partial differential equations? So it's very simple. If you take first two examples, so in this number of independent variables is equal to 1 only. And if you take third one and fourth one, number of independent variables are more than 1. More than 1 means either 2 or 3 or infinite. That is depends on the given example or given question. Okay. So if the differential equation contains or involving or having only one independent variable, then it is called an ordinary differential equation. If the differential equation contains more than one independent variable, then it is called partial differential equation. So now I am writing definition here. So what is the first one? An ordinary differential equation. So what is the definition? If the differential equation, DE means differential equation, contains or involving or having only one independent variable, then it is called an ordinary differential equation, ODE. And what are the examples for this? Example 1 and example 2. I am not writing again here, just I am giving that numbers. Clear? And coming to second one, what is that? A partial differential equation, PDE. So what is the definition of this one? If the differential equation contains more than one independent variable, then it is called a partial differential equation, right? And what are the examples for this? So now we'll consider example 3 and example 4. So that is the difference between ordinary and partial. Ordinary means it contains only one independent variable, but partial differential equation contains more than one independent variable, that is either 2 or 3 and so on, depends on the given question. Clear? Next topic is order and degree of a differential equation. Order and degree of differential equation means how to find order and degree for the given differential equation. Okay. Now again I am giving few more examples here. So one of the example, dy by dx 2xy equal to x cube. Second one is d square y by dx square 3 dy by dx whole cube plus 4y equal to 0. Third one is d square y by dx square plus 3y whole power 1 by 2 equal to 2 into dy by dx. So these are the given three examples. But here thing is how to find order and how to find degree. It's very simple. Suppose if you take first example, okay. So how many derivatives are in this? Only one derivative. So only one derivative means if we differentiate the given curve y equal to f of x, then we get dy by dx. Means we differentiated the given curve with respect to x once, only one time. So that order is equal to 1. And coming to degree, just we'll take the power of this derivative dy by dx. There is no power means what is the meaning of that word? So that degree is also equal to 1. And coming to second example, order and degree. So there are two derivatives in this. One is dy by dx, first order derivative. Another one is d square y by dx square, that is second order derivative. So in these two derivatives, which is the highest order derivative? D square y by dx square. Why? Because if I differentiate dy by dx again with respect to x, then only we get d square y by dx square. Means we differentiated 2 times. So that order is equal to 2. And for degree, the power of this highest order derivative, that is 1. So just write here equal to 1. And coming to third example, so d square y by dx square plus 3y power 1 by 2 means whole power equal to 2 dy by dx. So for this, order is d square y by dx square only. Why? Because this is the first order derivative, this is the second order derivative. And coming to degree, as of now, if we take this equation directly, we say that degree is not possible. Why degree is not possible? Because it has square root 2. 1 by 2 means square root. So if the differential equation contains either square root or cubic root means 1 by 3, or decimal values means 1 by 10, 1 by 100, 1 by 1000, etc. Then first we should remove that value. After that we will write or we consider degree for the given equation. Okay, so it has square root. Now do one thing. Just do SOB means squaring on both sides. Then how to write this equation? So I am writing here. Okay, now d square y by dx square plus 3y, right, whole power 1 by 2, again whole square, equal to 2 into dy by dx whole square. Now this 2 gets cancelled, right? Then what is the remaining value? D square y by dx square plus 3y. So that side 2 square means 4. It is dy by dx whole square. Okay. And coming to this is first order derivative, this is second order derivative. So second order derivative means order is equal to, what is that? 2. And coming to degree, so that is equal to 1. Well, because power of this highest order derivative is 1. So that degree is 1. Suppose if it is 1 by 3, right, power 3 on both sides. Suppose if it is 1 by 10, right, power 10 on both sides. If it is 1 by 100, right, power 100 on both sides. Okay, so first we should remove either square root or cubic root or decimal value. And one more example, that is example number 4. Suppose the given equation is d square y by dx square, then sine of dy by dx equal to 0. Now what is order and what is degree for that? So order equal to, what is that? 2. And coming to degree, we say that degree is not defined. Why degree is not defined? Because if I simplify this equation, then how to write it? Sine of dy by dx equal to minus d square y by dx square. Actually this simplification is not required, it is only for our understanding purpose. And from this, how to write dy by dx value? That can be written as sine inverse of minus d square y by dx square. Now see, derivative dy by dx is inside of this trigonometric function. If we simplify, again we will get the derivative, that is either first order or second order, that is secondary, but the derivative is inside of this trigonometric function. It is normal trigonometric function, it is inverse trigonometric function. So derivative is inside of that trigonometric or inverse trigonometric function, then degree is not defined. So that is the difference between this one and this one. And simply we say that it is not a polynomial. If it is a polynomial, then only degree is defined. If it is not a polynomial, degree is not defined. Clear? Now, what is the definition of order and what is the definition of degree? How to define that? If you take order, how to define this one? The order of a differential equation is the order of highest order derivative, highest order derivative occurring in it. Clear? And coming to degree, the degree of a differential equation is the degree of the highest order derivative. Highest order derivative, comma, when it is free from square root, comma, cube root or cubic root, and decimal values like 1 by 10, 1 by 100, 1 by 1000, etc. So these are the exact definitions of order and degree, and these are the examples. Okay, now we do that exercise, subjective part. Now see this example. This is NCERT example, okay. Find the order and degree if defined of each of the following differential equations. In that, this is the first question. What is the first question? dy by dx minus cos x equal to 0. Right? So here, what is order? This is first order derivative only, na? Order equal to 1. And the degree means power of this derivative, that is also equal to 1. Coming to second equation, xy d square y by dx square, and plus x into dy by dx whole square minus y dy by dx equal to 0. So here this is the highest order derivative, d square y by dx square, right? So order equal to 2. Coming to degree, what is the power of this highest order derivative? 1. So that equal to 1. And coming to third question, what is that? Y triple dash plus y square e power y dash equal to 0. Y triple dash means d cube y by dx cube, and it is y square, and e power dy by dx equal to 0. Actually, it is not a polynomial. Why? Because e power derivative is in power, right? So if it is not a polynomial, degree is not defined. But what is order? Order equal to 3. So degree equal to, what is that? Not defined. So this is the answer. The second example. Find order and degree of the differential equation y equal to x dy by dx plus square root of 1 plus dy by dx whole square. So what is the given equation? Y equal to x dy by dx, then square root of 1 plus dy by dx whole power 2. Right? Now this can be written as y minus x dy by dx and the square root of 1 plus dy by dx whole square. So actually it contains a square root, right? Now we should remove that. So how to remove that? Squaring on both sides. Then how to write LHS value? Y minus x dy by dx whole square, and that side square root of 1 plus dy by dx whole square, then whole power 2. Now square root cancelled, and this is a minus b whole square for a square. B square means x dy by dx whole square minus 2ab 2xy dy by dx, and coming to this side, that is 1 plus dy by dx whole square. Now how to write this? Y square, and it is x square dy by dx whole square, right? Then minus 2xy dy by dx minus 1 minus dy by dx whole square equal to 0. And in these two, dy by dx whole square is the common value. So if dy by dx whole square is common, then remaining is x square minus 1. Now dy by dx whole power 2. And write this one, minus 2xy dy by dx plus y square minus 1 equal to 0. Now what is order for this? Order equal to 1. But what is degree? Degree is equal to 2. That is the answer. This is the first exercise. Determine order and degree in bracket if defined of differential equations given in exercises 1 to 10. So if you take first example, means first question I mean, what is that? D power 4y by dx power 4. Sin of y triple dash means d cube y by dx cube equal to 0. So what is order? Order equal to, this is the highest order derivative 4. Coming to degree, so derivative is inside of this trigonometry function, so it is not defined. So this is the answer. And coming to second question, so y dash means dy by dx plus 5y equal to 0. Now order equal to 1. Degree is also equal to 1 only. And if you take this third equation, so ds by dt, d square s by dt square. So highest order derivative is d square s by dt square. So that order equal to 2. And coming to degree, what is the power of this highest order derivative? That is 1. And coming to this question, so order is equal to 2. But what is degree here? Degree is not defined. Why it is not defined? Because dy by dx is inside of this trigonometric function, means it is not a polynomial. Clear? And if you take this equation, means this question number 5, order equal to 2, degree equal to 1. And how to write this equation? Y triple dash d cube y by dx cube whole square. Y double dash means d square y by dx square whole power 3. Y dash means what is that? dy by dx whole power 4 plus y power 5 equal to 0. So which is the highest order derivative here? D cube y by dx cube. So order equal to 3. And what is the power of this highest order derivative? 2, na? So degree is equal to 2. So this is the answer. And if you take this equation, so d cube y by dx cube, right? 2 into d square y by dx square plus dy by dx equal to 0. So again order equal to 3. Why? Because this is the highest order derivative, right? And coming to degree, then we consider power of this highest order derivative. Power means that is equal to 1. And here how to write this equation? Dy by dx plus y equal to e power x. So order equal to 1. Degree is also equal to 1 only. Right? It is also polynomial. And coming to this, d square y by dx square plus dy by dx, what is that? Whole square plus 2y equal to 0. Now order equal to 2. And what is degree? Degree is equal to 1. Power of this highest order derivative. And how to write this equation? So d square y by dx square plus 2 into dy by dx plus sin y equal to 0. Now what is order? Highest order derivative is 2, so order equal to 2. And degree means power of that highest order derivative, that is 1. So degree is equal to 1. Oh, see this question, question number 11. So they asked only degree, right? So what is the given differential equation here? Given that d square y by dx square whole cube, dy by dx whole square, right? Then sin of dy by dx plus 1 equal to 0. Actually it is not a polynomial. Why? Because the derivative dy by dx is inside of this function. So degree is not defined. Just write here degree is not defined. Why it is not defined? Because it is not a polynomial. So what is the answer for this? Answer is D. So this is question number 12. They asked only order. So first we write given differential equation. Given that 2x square d square y by dx square minus 3 into dy by dx plus y equal to 0. So which is the highest order derivative here? D square y by dx square. So order equal to, what is that? Highest order derivative means 2. Suppose if you want a degree for this, so what is the degree? So degree means power of the highest order derivative. So power of d square y by dx square is equal to 1. Actually it's not asked this. If you want degree, we'll find like this. So order equal to 2 means which is the suitable option for that? A.